All right, this video is going to be on separable differential equations. So what a separable differential equation is it's a first order differential equation so if you recall, first order differential equation means that only the first derivative shows up in the equation, nothing else. Well, the first derivative and then whatever other variables are there. Where the expression for y prime or dy dx, you're going to see it written both ways, can be factored as a function of x multiplied by a function of y. And this is not necessarily factoring like using the diamond method, like factoring trinomials and that sort of thing. It could just be, really it's just that you're able to separate the x's and the y's from each other, where you could take all the y's as a group and move them to the other side of the equation. And you're doing so by multiplying or dividing them to the other side, not adding or subtracting. That's the really important part, is that you can move them without adding or subtracting them. So the instructions for these types of problems might say to separate the differential equation and we're going to add if possible there, because if you can't separate the x's and the y's from each other, then you're not going to be able to do anything with it. So for this one, we're going to say our first problem is y prime equals xy plus 2x. And I want to be able to get everything that has to do with y to one side and everything that has to do with x to the other side, is essentially what we're doing here. So instead of calling this y prime, I'm going to use the dy dx notation. So I'm saying this is the derivative in terms of y, the derivative in terms of x, as the y's are changing, as the x's are changing. So I know that dy is going to stay on the side with the y values, dx is going to go to the side with the x values. Over here, this is an actual factoring problem. I can see that I have a GCF of x that I can factor out. That leaves me with y plus 2. So if I want to get all the y's to the left side, then I'm going to go ahead and divide by y plus 2 over here. So I'm going to have 1 over y plus 2 dy. And then if I want all the x's on the right side, then I can leave this x that was by itself, and I can multiply that dx to the other side. So this is a separable differential equation, and I was able to separate the two sides based on the variables. All right, for the next one, we're going to say y prime is xy plus 2y squared. So again, I'm going to say dy dx so that I can think more clearly about getting my x's to one side and my y's to the other. This is factorable as well. I can see that I've got a GCF of y. And when I factor out that GCF, that leaves me with x plus 2y. And here, this would not be a separable differential equation because this factors in terms of x and y. There's no way for me to completely separate the x's from the y's. So that would be considered not separable.